If XLOOKUP is returning the wrong value, it usually isn't broken. It's doing exactly what you told it to do, just not what you meant. In most cases, the culprit is match mode or sort direction. And the tricky part is that the formula still looks correct at a glance. You get a result, so you trust it. But it's the wrong row, the wrong tier, or the wrong nearest match. In this video, you'll learn how XLOOKUP decides what counts as a match, when it picks the next smaller or next larger value, and how sorting changes everything. We'll also cover why approximate matching can silently fail when your data is unsorted, and how duplicates can make correct results feel random. By the end, you'll have a simple checklist you can apply in seconds. It works for prices, tax brackets, commissions, grading scales, and any lookup table with ranges. Next step. Let's ground this with the most common scenario. You look up a customer, SKU, or employee ID, and XLOOKUP brings back a value that belongs to someone else. That usually happens for one of three reasons. First, the lookup value isn't actually identical, even if it looks identical. Extra spaces, hidden characters, or numbers stored as text can cause XLOOKUP to miss the exact match and fall into another matching behavior. Second, you're using an approximate match mode without realizing it, or you copied a formula that uses it. Third, your lookup array has duplicates, and XLOOKUP returns the first match it encounters, not the best match. So the goal is to diagnose which bucket you're in before changing anything. In practice, you start by confirming whether you want exact match only, or you actually want nearest behavior like bracket tables. That single decision determines the correct match mode. Next step. Here's the mental model. XLOOKUP has three jobs. Job 1 is to find a position in the lookup array. Job 2 is to return the value from the return array at that same position. Job 3 is to decide what to do when it can't find an exact match. That third job is where most wrong value problems live. The match mode argument controls that behavior. If you leave it blank, XLOOKUP uses exact match. If it can't find one, it returns #NA, which is actually a good thing because it's honest. But when match mode is set to an approximate option, XLOOKUP will choose a nearby value instead of failing. That can be perfect for tiered pricing and ranges. It can also be disastrous for IDs and names. So before you tweak anything else, read your own formula and identify whether match mode is blank, 0, -1, or 1. That tells you what XLOOKUP is trying to do. Next step. Let's break down match mode in plain language. 0 means exact match only. If there's no exact match, you get -NA. -1 means exact match or next smaller item. That's the classic bracket behavior, like tax rates, where you want the largest threshold that is still less than or equal to the value. 1 means exact match or next larger item. That's useful when you want the smallest threshold that is greater than or equal to the value, like minimum order quantities. There's also match mode 2, which is wildcard matching for text, using characters like asterisk and question mark. Wildcards are powerful, but they can also match more than you intended, especially with similar product names. The key point is this. Approximate modes are not close enough in a human sense. They are strictly next smaller or next larger based on sorting. If you pick the wrong direction, your result will be consistently wrong. Next step. Now we hit the part that surprises people. Approximate match modes depend on sort order. If you use next smaller or next larger, your lookup array must be sorted correctly, or XLOOKUP can return a value that's simply not the nearest threshold. Think of it like searching a dictionary. If the words aren't alphabetized, nearest becomes meaningless. For next smaller and next larger, you typically need ascending order. If your thresholds are in descending order, the logic flips, and results can jump to the wrong bracket. This is why you might see the right answer for some inputs and completely wrong answers for others. It's not random. It's the search algorithm working on messy input. So the fix is not to try another match mode until it works. The fix is to decide the intended behavior, then enforce the required sort order in the lookup table. If you can't guarantee sorting, you should avoid approximate match and redesign the approach. Next step. This is where the search mode argument enters. Search mode controls the direction XLOOKUP searches through the lookup array. 1 means search first to last. -1 means search last to first. There are also binary search options, 2 and -2, which are faster but require strict sorting. For wrong value issues, the big practical use is handling duplicates. If your lookup array has repeated keys, XLOOKUP will return the first match it finds based on search direction. So if you want the most recent entry, you often want to search from last to first. That's not a match mode problem. That's a search mode choice. Another subtlety: if you use binary search with unsorted data, you can get incorrect results without any warning. So unless you control sorting tightly, stick to the default linear search. Speed matters, but correctness matters more. First make it right, then make it fast. Next step. Let's walk through a classic tier table example, because it's where approximate matching is actually the right tool. Imagine a commission table with thresholds: 0, 10,000, 25,000, 50,000. Each threshold has a commission rate. If a salesperson has 32,000 in sales, you want the 25,000 tier, not the 50,000 tier. That means you want the next smaller threshold. So your match mode should be -1, and your thresholds must be sorted ascending. If someone sorts the table descending because it looks nicer, your results can shift to the wrong tier. If you instead choose match mode 1, you'll jump up to the next larger tier, which overpays commission. The takeaway is simple. For bracket tables, write down the rule in words first. Do you want the largest threshold below the value or the smallest threshold above it? Then pick match mode to match that sentence. Next step. Now let's handle the other common case. You wanted an exact match, but you got a nearby value because your data isn't truly clean. Even with match mode set to 0, people often think XLOOKUP is wrong when the real issue is the key. For text keys, extra spaces are the #1 culprit. A trailing space makes two names look identical, but compared differently. For codes, leading zeros can turn a number into text or vice versa. And for imported data, you can get non-printing characters that don't show up. The practical fix is to normalize keys. Use trim to remove extra spaces, use clean if the source includes odd characters, and make sure both sides are the same type, either both text or both numbers. If you're dealing with IDs that must keep leading zeros, store them as text consistently. Once the keys are normalized, exact match becomes reliable, and you stop chasing ghosts in the formula. Next step. Duplicates deserve their own quick strategy, because they create the feeling that XLOOKUP is unpredictable. It isn't. If your lookup array contains the same key multiple times, XLOOKUP returns one of them based on search direction. If you expected a unique result, the real fix is to enforce uniqueness. That can mean using a unique ID instead of a name, or combining fields into a composite key like customer ID plus date. If duplicates are legitimate, then you need to decide which record you want. The first one? The last one, the one with the highest status? XLOOKUP alone can only pick by position, not by best match logic. Search mode -1 is great for latest record wins. For more complex rules, you may need to filter the table first, or use helper columns that rank records. The key is to stop asking XLOOKUP to make a business decision you haven't defined. Next step. Let's talk about a safe troubleshooting checklist you can run in under a minute. First, confirm the lookup value. Copy it and check for spaces or type issues. Second, verify the lookup array and return array are aligned and the same size. Misaligned ranges can return a value from the wrong row, and it looks exactly like a matching problem. Third, check match mode. If you're doing IDs, it should almost always be 0 or blank. If you're doing brackets, decide between -1 and 1. Fourth, check sorting when using approximate matches. Make sure thresholds are in the correct order. Fifth, if duplicates exist, set search mode intentionally, or redesign the key. Finally, consider using the if not found argument to return a clear message instead of a confusing error. That doesn't fix wrong values, but it makes failures obvious, which prevents silent mistakes. Next step. A few best practices will prevent most wrong value situations before they happen. Keep your lookup tables structured and stable. Use dedicated columns for keys, and don't mix types in the same key column. For bracket tables, store thresholds as numbers. Sort them once, and protect that sort order. If someone needs a different view, create a separate view instead of resorting the source. Prefer exact match for anything that should be unique, like IDs, emails, and SKUs. Use approximate match only when your business rule is explicitly next smaller or next larger. And be careful with wildcards. They're great for controlled patterns, but risky for free-form names. Finally, document the intended behavior in a short note near the table, like thresholds ascending, use -1. That tiny bit of clarity saves hours of debugging later, especially when someone else inherits your workbook. Next step, let's wrap it up with the simplest way to think about this. If XLOOKUP returns the wrong value, don't start by rewriting the formula. Start by asking 2 questions. 1. Should this be an exact match or a nearest match? 2. If it's nearest, do I want next smaller or next larger? And is my table sorted to support that? Then check for duplicates and decide whether you want the first or last match. Once those decisions are clear, XLOOKUP becomes very predictable. It stops being a mysterious black box and turns into a reliable tool you can trust. If you want, you can take one of your own wrong value examples and apply the checklist step by step. You'll usually find the issue in match mode, sorting, or duplicates. If this breakdown helped, subscribe for more practical Excel problem solving. And in the comments, tell me which issue you hit more often, match mode confusion or unsorted lookup tables. Subscribe to keep optimizing your workflow and get back more of your time.